Welcome everyone to this podcast about Pokémon facts from Generation 3. This is Decoding the Dark. If you like these kind of videos, please leave a like and subscribe. Let's begin today's topic.
We're talking about Pokémon Generation 3, so that's Ruby, Sapphire, Emerald, and then the remakes, Fire Red and Leaf Green, the Advance era.
A massively pivotal moment in gaming history. We were talking roughly 2002 to 2006. Transition from the Game Boy Color hardware to the Game Boy Advance.
Right, and the popular memory of these games, or at least, my memory of them, is that they were incredibly vibrant. They were so polished.
Absolutely.
You had the reflections in the water puddles, you had the moving trucks, the secret bases. It just felt like a massive, massive upgrade.
Visually and artistically, it was a huge leap forward. I mean, It really defined the aesthetic of Pokemon for a decade.
But underneath that shiny coat of paint, the foundation was cracking. Seriously cracking.
Oh, yeah.
We aren't just talking about funny bugs where your character accidentally walks through a wall. We are talking about catastrophic mathematical failures here.
Total structural breakdown.
We have time travel glitches that literally froze the world for millions of players. We have legendary Pokemon that are statistically ruined the very moment you look at them.
Yeah, the roaming ones.
And we have a berry, a literal piece of digital fruit that lets you rewrite the game's source code while you are playing it.
It really is a masterclass in how fragile software architecture can be when you're dealing with a hard reboot. And I think that's the context we really have to start with here. The technical reboot.
Right, the infamous data wall.
Exactly. You have to think about the mindset of a player back in 2002. If you were a kid playing red, blue, gold, or silver, you had poured hundreds of hours into those cartridges.
You had your level 100 Charizard, your shiny Gyarados from the Lake of Rage.
Right. But when Ruby and Sapphire dropped on the Game Boy Advance, you hit a wall. A hard wall. You could not trade your old Pokemon forward.
I remember the devastation vividly. If you're listening and you played back then, you know exactly what I mean. It felt personal. It felt like they were erasing our childhood achievements.
It definitely felt personal to the players, but it was purely architectural. The developers made a very, very difficult decision. They decided to just cut ties with the legacy code of the Game Boy Color era entirely.
They wanted to modernize the math behind the monsters.
Exactly. They built a completely new data structure from scratch. And the mission for our deep dive today is to see exactly what happened when they tried to build that massive skyscraper on a very tight deadline.
So this wasn't just a case of, oh, we forgot to buy the link cable. This was essentially, we speak a completely different language now.
Precisely. And it seems like the problem started right at the core of that new structure, specifically the personality value.
PID. I see this term all over the research notes.
Yeah, the PID is basically the DNA of a Gen 3 Pokemon. In the old games, Gen 1 and 2, data was efficient for the time, but it was very restricted.
How so?
Well, a Pokemon's stats, its gender, its shininess, they were all tied together in a very restrictive knot. For example, if Pokemon had high attack stats, or IVs, it actually had to be male in certain species.
Wait, really?
Yeah, or if it was shiny, it had to have specific, slightly lower stats across the board.
So you couldn't have a perfectly strong, shiny Pokemon?
In Gen 2, essentially no. Perfection and shininess were mutually exclusive because they used the exact same bits of data to determine both of those things.
That sounds incredibly frustrating if you're a completionist.
It really was. So for Gen 3, they wanted to decouple everything. They introduced a personality value. It's a 32-bit integer.
32-bit, that sounds pretty standard now, but for a handheld in 2002, that was a lot of headroom.
It was a massive amount of data. A 32-bit integer allows for over 4 billion unique combinations. 4,294,967,295 to be exact.
Wow.
And this single string of code determines the gender, the nature, the abilities, which are a brand new mechanic in Gen 3 and whether the Pokemon is shiny or not.
So instead of everything being tied to how strong the Pokemon is, it's tied to this completely random ID number.
Correct.
Yeah.
It allowed for the different unknown forms, Spinda's unique spots, Wurmple's random evolution path. It made every single Pokemon feel mathematically unique.
But introducing a 32-bit system into a game engine that was being somewhat rushed out the door created vulnerabilities.
Always. Complexity always invites chaos.
And we see that chaos pretty early on, even in just how the games were localized. We have a whole section in the notes here on regional divergence. It seems like the Japanese version of Hoenn and the international version are slightly different dimensions.
They really are. The localization process back then just wasn't as streamlined as it is today. They were constantly tweaking things on the fly.
Let's talk about the start button mystery. This one is small, but it kind of drives me crazy now that I know about it.
It's one of my favorites purely because it is so mundane, yet so incredibly specific. In the Japanese releases of Ruby and Sapphire, and the remakes Fire Red and Leaf Green, the title screen text says, press start button.
Okay, clear instructions. You press the button labeled start.
But in the English and international releases, they changed it to just press start.
They deleted the word button.
They deleted button.
Why?
It's likely an aesthetic choice regarding the physical spacing on the screen. Press start button is a bit long, and maybe the font size in English made it look cluttered. Or perhaps the localization team felt adding button sounded slightly too robotic. But it sets the tone. They were tweaking absolutely everything. Look at the sprites.
Hexmaniac.
Yeah, the Hexmaniac is a trainer class you find in caves or spooky areas. In the Japanese ROM, if you look closely at her sprite, her eyes are completely blank. Just pure white space. No pupils at all.
She looks completely possessed.
She looks like a reanimated corpse or some kind of ghost. It is genuinely unsettling for a game aimed at young children.
I can definitely see why they'd want to change that for a global audience.
Exactly. So, for the international release, they went in and added tiny little pupils to her eyes.
Just to make her look, I don't know, alive.
To make her look less like a horror movie villain and more like just a weird goth kid who hangs out in caves. It is a very subtle shift in tone, but it changes the character entirely. But then you have the sailor.
Yeah, the notes here say the sailor was offensive. How on earth can a sailor be offensive?
So, in the Japanese version, the sailor trainer class has this specific battle pose. One hand is raised up, the palm is facing inward, and the arm is bent at the elbow. To a Japanese audience, it's just a tough guy pose, like he's flexing his bicep or getting ready to grapple.
Okay, seems normal enough.
But in parts of Europe, specifically Spain, France, Italy, and also in Latin America, that exact gesture heavily mimics the Iberian slap or the brought on oar.
Which is the equivalent of
flipping someone the bird. It's a very rude, very aggressive screw you gesture in those cultures.
Wow. So imagine you're a 10-year-old kid in Madrid, you challenge a regular sailor on the beach, and he effectively gives you the middle finger before throwing a Pokeball.
Exactly. You want a battle, take this. So for the international release, they completely redrew the arm to just hang down by his side. Crisis averted.
That is a legitimate save by the localization team right there. That could have been a massive PR nightmare. But then you have the cultural stuff too, the TV shows. I love this detail because it feels like the translators were just having a lot of fun with their jobs.
It really shows how much freedom the localization teams had back then. You know how you walk into a house in the game, you check the TV, and it gives you a little line of flavor text?
Yeah, it says something like, "There is a movie on TV."
Right. In the standard international English version, a male player sees a reference to Stand By Me. It says something about boys walking on railroad tracks. A female player sees a reference to The Wizard of Oz, a girl in red shoes walking on a yellow brick road.
Classic adventure tropes. It perfectly matches the journey you're about to take.
It does. But the French localization team just went totally rogue. In the French version, if you're playing as a boy, the text references the movie Taxi.
Taxi. The Luc Besson action comedy about a crazy taxi driver in Marseille.
That is the one. Fast cars, French hip-hop, just a very, very different vibe from the nostalgic Americana of Stand By Me.
And the girl player.
The girl gets the Lord of the Rings.
Wait, the French girl's got Lord of the Rings. That is a massive upgrade over Wizard of Oz.
It's fascinating, right? They weren't just translating the words verbatim. They were actively swapping out the cultural touchstones for what they thought French kids in 2003 would recognize and think was actually cool. Taxi was huge in France at the time.
That makes sense. But sometimes these regional changes weren't just cosmetic text or sprites. They actually changed the level design, the Victory Road ledge.
Yes, this is where localization literally impacts the difficulty of the game. In the Japanese and English versions, on floor B1 of Victory Road, there is a physical ledge blocking a shortcut to a ladder. You have to take a long way around to get past it. It adds friction. It makes the dungeon demonstrably harder.
I remember getting so lost in there. Victory Road in Hoenn was an absolute maze.
Well, if you played the German, Spanish, French, or Italian versions of the game, that ledge is just gone.
Gone, like missing.
Just removed.
Yeah.
The map data is fundamentally different. You can walk straight to the ladder without going around.
Did they think European kids couldn't handle the navigation puzzle?
Who knows? Maybe the European QA teams were playing through it during the translation process and just said, this is annoying, let's delete it. We don't really know the intent, but it is a tangible gameplay difference based solely on where you bought the physical cartridge.
That's wild. So if you were doing a speedrun of the game today, the language you choose actually matters for your routing.
Absolutely it does. The architecture is slightly different. But speaking of architecture, we need to transition and talk about the actual cracks in the foundation, the structural failures. And the first one we have to cover is the one that literally stopped time.
The berry glitch.
This was the big one.
I remember the rumors about this on the playground so clearly. Kids saying, don't play your game for too long. If the battery dies, the whole game breaks.
Yeah, we really need to separate the hardware from the software here, because there is a very important distinction to make. The Game Boy Advance cartridges for Ruby and Sapphire had a real-time clock, an RTC chip, embedded in them. And that chip was powered by a physical battery, usually a CR1616 watch battery.
Right.
This clock ran 24/7, even when the Game Boy was completely powered off. It controlled berry growth, the changing tides in Shoal Cave, the daily lottery, the department store sales in Lily Cove.
And eventually, of course, that battery dies. I have cartridges right now in my drawer where the battery's completely dry.
Right, and when the battery dies, the clock stops. That is a basic hardware failure. The game even gives you a message when you boot it up. The internal battery has run dry. The game can be played. However, clock-based events will no longer occur. That is entirely expected behavior for a dead battery.
Okay.
The berry glitch was something else entirely. This was a massive coding error that froze time while the physical battery was still completely fresh.
So you have a perfectly working battery, but the game thinks time has just stopped.
Correct.
What triggered it?
It occurs roughly one real-time year after you start your save file, specifically right around day 366.
Why 1 year? Why does the game just give up after a single year?
It's a fundamental logic error in the calendar program itself. The game tracks days internally using a simple counter. When the calendar tries to transition from year 1 to year 2, so moving from day 365 to day 366 and attempting to reset back to a year 2, day 1 state, the lookup table that converts the raw timestamp into a readable date fails to carry the 1, so to speak. The internal logic just gets stuck in a loop.
It's basically a mini Y2K bug on a Game Boy.
It is exactly like Y2K. The processor gets so confused about what day it actually is, so it just stops updating the day counter entirely. It effectively freezes the in-game calendar to avoid completely crashing the game.
And the consequences of that freeze.
Berries never grow. If you planted a Lepa berry, it stays a tiny sprout forever. The tides in Shoal Cave freeze at whatever exact state they were in when the glitch hit. So if it was high tide, you can never get the low tide items like the shoal salt. There's no more daily lottery. The entire world just becomes static.
And this was affecting every single copy out there.
Every single early copy of Ruby and Sapphire. Millions of units worldwide. It was essentially a ticking time bomb built into the code. And Nintendo quickly realized they had a massive problem on their hands. Remember, they couldn't just patch the internet. The GBA wasn't an online console.
Right, they couldn't just push a day 1 update over Wi-Fi like they do now.
No, so they had to do a physical recall, but they handled it in a very clever way. They knew they couldn't ask 5 million kids to mail their cartridges all the way back to Japan or to a service center. So they created these Trojan horse fixes.
I love this part of the history. It feels like a covert repair operation.
It really was. They distributed the Berry program update through other games and promotional events. The most famous one was the Shiny Zigzagoon distribution.
Right, you could go to a GameStop or a Target to get it.
Exactly. You would take your physical Game Boy Advance and your broken cartridge to the retail store.
Yeah.
They had a GameCube set up running a special interactive demo disc. You plugged your GBA into the GameCube using the link cable. The GameCube would detect the Ruby or Sapphire cartridge, inject a tiny piece of code to permanently fix the calendar logic, and as a, hey, sorry for the inconvenience, it would upload a shiny Zigzagoon holding a lychee berry directly into your party.
And a lychee berry was super rare, right?
Oh, incredibly rare. You couldn't get it in normal gameplay at all. It was exclusive to this specific patch and one other inaccessible island. So they basically bribed us. Here is a shiny Pokemon and a super rare fruit. Please forgive us for breaking your calendar.
I mean, it worked on me. I would have broken my game on purpose just for a shiny back then. But they also hid the patch in other actual games too, right?
Yes, they did. If you linked your Ruby or Sapphire cartridge to Pokemon Coliseum or Pokemon XD Gale of Darkness on the GameCube, those console games would silently patch your GBA cartridge in the background.
Without even telling you.
Without telling you. It would detect the internal version number, see that it was unpatched, and fix the calendar code while you were just trading Pokemon back and forth. But the coolest, most secretive method was definitely built into Fire Red and Leaf Green.
This secret menu, this absolutely blew my mind when I read the research notes.
This is pure developer spycraft. When Fire Red and Leaf Green launched, they contained the patch code within their own files. If you traded normally with an unpatched Ruby copy, it would fix it. But what if you didn't want to trade? What if you just wanted to use your new game to fix your old game?
There was a button combo.
If you were sitting at the title screen of Fire Red or Leaf Green, and you just hold down Select and B, just the 2 buttons.
Does it say press Select and B anywhere on the screen? Is there a hidden prompt?
No, it is completely invisible to the player. But if you press it, the screen instantly changes to a very plain, basic menu that just says Berry Program Update. It essentially turns your Game Boy Advance into a dedicated repair tool. You link it to the broken Ruby cartridge using a cable, and it transmits the patch over.
That is just amazing. It really shows how desperate they were to squash this bug. They built a secret, undocumented repair service into the sequel just to make absolutely sure they caught as many broken cartridges in the wild as possible.
It was damage control on a truly massive scale. But at least the berry glitch didn't ruin your actual Pokemon. It just stopped the clock. The next architectural failure we need to look at, this one actually destroyed the Pokemon themselves.
The roaming fife glitch. This is the one that really hurts to think about.
This one is just tragic for anyone who put the time in.
We all did this. If you played, you did this. You beat the Elite Four, you wake up in your room, you go downstairs, and you watch the TV report about a mysterious flying Pokemon. You spend literally weeks tracking Latios or Latias around the tall grass on the map, or in Fire Red, you chase Raikou, Wontai, or Suicune.
The roaming legendaries, the absolute ultimate prize for a dedicated trainer.
You finally catch it, you use your Master Ball, or you get lucky with an Ultra Ball. You excitedly check its stats, and it's terrible.
It's not just terrible, it is mathematically fundamentally broken.
Explain the math to us. Why were my roaming legendaries always so pathetically bad?
Okay, remember that 32-bit integer we talked about earlier? The massive data string that holds all of the Pokemon's unique info.
Yes. The PID and the IVs.
Right. When a Pokemon is generated by the game, it gets individual values, or IVs, for each of its stats.
Yeah.
HP, attack, defense, speed, special attack, special defense. These randomly range from 0 to 31. 31 is mathematically perfect. 0 is, well, it's 0.
Right. It's as bad as it gets.
For a normal wild encounter, like a Pidgey in the grass, the game generates the full 32-bit string and saves it instantly. But for roaming Pokemon, the game has a unique problem. It has to store their exact data in a temporary memory slot while they move around the overworld map. Because they aren't actually in a battle with you, they're just abstract data floating between routes. When you finally encounter them and catch the Pokemon, the game has to retrieve that temporary data and copy it over to your permanent party or PC box.
Okay, that makes sense. Just a standard copy-paste function behind the scenes.
Exactly. The problem lies entirely in the specific command the developers used for that copy-paste function. They use what programmers call a mask. A mask is basically a way of telling the computer which specific parts of the data string it should look at and grab. To read the full 32-bit integer properly, they should have used a hexadecimal mask of 0 by 3 FFFFFF. That long string covers the entire chunk of data.
Okay, following so far.
Instead, somebody made a typo. They used a mask of simply 0 IFFF.
0xFF. For those of us who don't natively speak hexadecimal, how big is that compared to what it should be?
That mask is only 8 bits long.
Wow. They tried to fit 32 bits of crucial data into an 8-bit bucket.
Exactly. They truncated the data severely. The copy-paste command only looks at and copies the very last 8 bits of the integer, and it completely ignores the rest.
And what exactly lives in those last 8 bits?
Just the HP stat calculation.
So the HP is fine.
HP is usually totally fine. It generates normally. But because of the cutoff, the attack half-D is artificially capped at a maximum of just 7 out of 31. And the defense, special attack, special defense, and speed. Because those bits are completely outside the 8-bit mask, they are wiped out entirely. They're permanently set to 0.
0.
0. Every single roaming Latios, Raikou, Entei, and Suicune caught in the original Ruby, Sapphire, Fire Red, or Leaf Green versions has 0 defense, 0 speed, 0 special attack. Guaranteed.
So my Latios, which is supposed to be this incredibly fast, hard-hitting, special attacking jet plane dragon,
is literally the slowest, weakest version of itself possible in the game. It is statistically handicapped from the second the TV report generates it.
That is just heartbreaking. You spend all that time chasing it around the map and you catch a total dud.
It renders them completely competitively worthless. If you wanted a legitimately good Latios in Gen 3, you had to get the Southern Island event ticket because that specific encounter was static. It just stood there, it didn't roam, so the temporary memory code didn't break its stats. Or you had to wait a few years for Pokemon Emerald. They finally found the mask error and fixed it in Emerald.
But Fire Red and Leaf Green had an even nastier bug for the roaming beasts, right? The roar glitch.
Oh yeah, this is the absolute cherry on top of the disaster sundae. If you finally encounter Entei or Raikou in the wild, and they use the move Roar to forcibly end the battle.
Which forces your Pokemon to run away and ends the encounter.
Right. The game logic interprets that very specific end-of-battle condition completely incorrectly for roaming flags. It flags roaming Pokemon as defeated instead of fled.
So the game thinks I killed it.
It thinks you knocked it out. The roaming beast disappears from the map and from your save file forever. You can never encounter it again.
Imagine finally finding a shiny Raikou after weeks of hunting. It uses Roar on turn 1, and it's just gone.
Gone forever.
Oh.
You'd have to restart the entire game. It really highlights just how incredibly fragile the whole roaming mechanic was. They were trying to create this dynamic, persistent world where monsters actively moved around the map, but the underlying code just wasn't robust enough to handle the mathematical edge cases.
Speaking of edge cases, I think we have arrived at the main event of today's deep dive. We've talked about broken clocks and we talked about broken stats. Now we really need to talk about broken reality. The Pomeg glitch.
This is jumping straight into the deep end of the pool. The Pomeg glitch isn't just a bug. It is a direct gateway to arbitrary code execution, or AC.
ACE? I mean, that sounds like straight up hacking.
It is hacking, fundamentally. But you are doing it exclusively with the physical buttons on your Game Boy, using the game's own internal rules against it. You don't need a Game Shark or an action replay, you just need a berry.
And it all starts with the Pomeg berry.
Right. In Pokemon Emerald, the developers gave the Pomeg berry a brand new function. If you feed it to a Pokemon, it lowers their HP effort values, or EVs, to make them friendlier toward the trainer.
Okay, let's do a really quick refresher on the math for everyone listening. Max HP is calculated how?
Max HP equals the Pokemon's base stats, plus their IVs, plus their EVs.
So if I use a berry to lower the EVs, the overall max HP number should go down.
Correct. The game dynamically recalculates the max HP right then and there, and usually it runs a very basic safety check. It asks, is the current HP greater than the new max HP? If yes, lower the current HP to match the new ceiling.
Makes perfect sense. If I have 100 out of 100 HP and my max drops to 90, my current HP should drop to 92.
Exactly. But what if you have a Pokemon with very low health to begin with? Let's say you have a Pokemon that survived a battle with exactly 1 HP left, and you use a Pomeg berry that drops its max HP significantly. There was a glaring loophole in the subtraction calculation.
What happens?
The calculation for the current HP underflows.
Underflow. That's when a number in a computer goes below 0 and loops all the way back around to the maximum possible value, right? Like a car odometer rolling backwards past 0.
That is exactly what it is. The computer tries to subtract, it goes below 0, and because it's an unsigned integer, meaning the code doesn't allow for negative numbers to exist, it completely wraps around to the maximum possible number that memory address can hold. Specifically, the current HP becomes 65,535, or sometimes it visually displays on the screen as $35 in glitchy text.
But wait, if I suddenly have a Pokemon with 65,000 HP, isn't that an incredible thing? I'm basically invincible.
It would be incredible, except the game also simultaneously registers that the HP dropped to 0 during the math calculation. So the game flags the Pokemon as fainted, but it also has infinite health.
It's a zombie.
It is entirely a Schrodinger's Pokemon.
Yeah.
It is dead and alive at the exact same time. And because it technically has HP remaining, the game lets you keep it in your party as your final conscious Pokemon. You don't white out. But because it is flagged as fainted, if you actually enter a battle with it, the game logic completely panics.
And this panic leads to what the community calls glitzer popping.
Yes, glitzer popping. If you send out this zombie Pokemon into a battle, or you interact with it in very specific ways in the menus, you can actively corrupt the memory state of your entire party.
And this allows you to scroll, like physically scroll the menu.
Yes, this is the visual representation of that memory corruption happening in real time. You know the standard Pokemon summary screen?
Yeah.
Press up or down on the D-pad to check the next team member's stats.
Right, going from slot 1 through slot 6.
Glitzer popping breaks the restrictive boundary of that menu array. You can actually scroll up past slot 1, go to slot 0, then slot -1, slot -2.
But those slots don't exist in the game.
They don't exist in the party definition, no. But the memory addresses physically located next to the party data in the RAM certainly exist. The game just dutifully starts reading whatever raw data is next door to the party as if it were a Pokemon.
And what exactly lives next door to the party in the RAM?
The PC boxes.
Oh.
Yeah. So by scrolling up past your party limit, you are actively forcing the game engine to read your stored PC box data as if it were a living Pokemon in your party.
And this is what creates the decamark.
Yes, the 10 question marks. This is the game engine desperately trying to interpret raw PC storage data as a physical monster. It usually looks like a glowing question mark inside a black circle, or sometimes it's labeled as a bad egg. But here is the absolute genius part of the exploit. Since the game is reading the PC data as code, if you change the PC data, you are changing the code.
And how do I change PC data?
By naming things. The nicknames you give the Pokemon sitting in your boxes, the names of the boxes themselves, those letters and symbols are stored as text characters. Each character corresponds to a specific byte of hexadecimal data.
Wait, you are telling me that if I name my PC box A versus naming it B, I am literally changing the underlying code the game executes when I scroll up.
Precisely. You are using the in-game alphabet screen to write raw assembly language. Dedicated players have meticulously mapped out specific box names that, when read by the glitzer popping glitch, act as direct computer instructions.
Instructions to do what, exactly?
Anything. Literally anything. You can write a short text script that instantly warps your character to Nail Rock to catch Lugia. You can warp to Birth Island for Deoxys. You can trigger the flags to complete the National Dex instantly. People have even programmed entirely new playable minigames, like Snake or Tong, inside of Pokemon Emerald's engine using just this method.
That is genuinely mind-blowing. You are basically entering a hidden developer mode just by rearranging your digital furniture.
It is the holy grail of glitches. It transforms the game from a closed, restrictive loop into an open sandbox. And it is all because one programmer didn't put a proper negative number safeguard on the Pomegberry HP calculation. That one missing check unlocks the entire matrix of the game.
It's incredible that this was just sitting there for years undetected. I mean, we were just kids sitting on the bus trading Groudons, and meanwhile, we had the literal keys to the universe sitting in our pockets.
And the technical community is still finding new scripts and applications for it today. It's an active field of research. It's arguably the most complex and robust glitch in console gaming history.
Now, for those of us listening who maybe aren't computer scientists, there was a much simpler glitch in Emerald, the Battle Tower cloning glitch. I definitely used this one back in the day.
This one is much more accessible. No mathematical underflow or hex editing required.
It felt illicit, though, like I was printing money in my bedroom.
You essentially were. It relies on the way the game architecture saves data, specifically at the battle frontier.
Walk us through the physical mechanism of the clone.
Okay, when you go to the Link multi-battle receptionist inside the battle tower, she asks you to save the game before you enter.
The classic, saving, don't turn off the power message.
Right. The game architecture actually saves party data and PC data completely separately. There's a microscopic split-second lag between writing one block and writing the other.
So the player strategy is to interrupt that lag.
Exactly. You put the Pokemon you want to clone, let's say a Rayquaza holding a Master Ball, into a PC box. You save the game normally, that creates your anchor state.
Got it. Rayquaza is safely in the box on the hard save.
Then you withdraw that Rayquaza into your active party. You walk over to the receptionist. She asks you to save. You say yes. But, and this is the crucial trick, you turn off the power or soft reset the game right after the system finishes writing the party data, but immediately before it overwrites the PC data.
So when I reboot the Game Boy,
the game loads the party from the interrupted save. So your Rayquaza is sitting in your hand, but it loads the PC from the original anchor save, where Rayquaza is also still sitting in the box.
2 Rayquazas, 2 Master Balls.
And you could easily do this with up to 6 Pokemon at a time if you filled your party. It completely and utterly broke the economy of the game. Rare candies, rare TMs, competitive legendary Pokemon, Scarcity simply ceased to exist.
It's kind of funny that Emerald fixed the complex roaming of fifth glitch and removed the Victory Road ledge, but then accidentally introduced the easiest, most broken cloning exploit in the entire series.
It just shows that as you add new features, like a massive battle frontier area, you open entirely new doors for system errors. The more complex the system gets, the more likely it is to break in unexpected ways.
I want to jump into some of the weird, really obscure stuff now, the deep cuts from the notes. You mentioned something about surfing on land.
Oh yeah, this is a Japanese exclusive visual glitch. It's very strange. On Route 118, there's a specific spot right near the water's edge. If you have the acro bike, the one that lets you do bunny hops, and you time your hop absolutely perfectly at the boundary of the water tile, you can trick the game's state machine.
The state machine? What's that?
It's the core code that tracks what the player is currently doing. Is the player walking? Is the player surfing? Is the player cycling? By hopping at the exact right pixel, you can confuse it. The game puts you into the surfing state, so visually you are riding on the back of your Whalmer or Tentacool, but it doesn't restrict your physical movement to water tiles.
So you can just land shark your way through the tall grass.
Precisely. You just float over the dirt. It looks completely ridiculous. But in the international versions, the developers tightened the collision detection in the code, so you just bounce back instead of entering the surf state.
And then there's the e-reader, that incredibly chunky card swiper thing that clicked into the top of the Game Boy Advance.
A fascinating failure of a peripheral. In Japan, they leaned heavily into it for Gen 3. They released physical paper cards that contained barcode data for brand new exclusive berries. You had the pumpkin berry, the drashberry, the agate berry.
I have played hundreds of hours and I have never heard of a drashberry.
Because they don't actually exist in the base ROM of the game. When you swipe the card through the e-reader, it injected the berries data, the visual sprite, the flavor text, the stat effect, directly into the game's RAM.
Okay, so the berry lives in your personal save file, not in the permanent game code.
Right. But here is where the paradox happens. What happens if you take a Pokemon holding a drashberry and you trade it up to Diamond or Pearl on the Nintendo DS a few years later?
Well, Gen 4 doesn't have the e-reader at all.
Exactly. Gen 4 has absolutely no idea what a drashberry is. It's not in the DS code. So if you force the transfer, the game panics and the berry transforms into an item called an Enigma berry.
The Enigma berry. I remember seeing that name on old cheat lists and wondering how you were actually supposed to get it.
It's basically a placeholder. It is the game engine saying, I know you're holding an item, and I know it is categorized as a berry, but I have completely lost the data that tells me what it looks like or what it does. It is essentially a digital tombstone for lost content.
That is strangely poetic for a Pokemon game, a piece of fruit that exists only as a memory of data you can no longer read.
It really highlights the issue of video game preservation. Those specific berries are physically lost to time unless you happen to own the original Japanese paper cards and a working e-reader peripheral.
Speaking of lost content, we really have to address the elephant in the room from the research, or maybe the burnt forest in the room, the 2024 leaks.
The Terra leak. This fundamentally changed how the community looks at Generation 3 entirely.
We found developer files referring to something called Pokopia.
Pokopia.
I know, sounds cute. Sounds like a spin-off mobile puzzle game. But the internal data suggests it was a code name for a massive project intended to revisit the Kanto region during the Gen 3 era, maybe as an alternative concept to what eventually became Fire Red and Leaf Green. But this wasn't the nostalgic Kanto we all know and love.
No, not at all. The leaked map data and the concept art clearly point to a post-apocalyptic setting.
Define post-apocalyptic in Pokemon terms for me. How bad are we talking?
The internal text files describe Viridian Forest, which is usually this peaceful early-game bug-catcher paradise, as a burning ash heap, a literal never-ending forest fire.
That is incredibly dark for a kid's game.
It gets worse. Pewter City is described as a totally abandoned mine, just covered in rocks and debris, no gem, just rubble. And Vermilion City, the Sunnyport town where the cruise ship docks. It's described as a constantly raining, completely flooded electrical harbor.
So basically, fire, earth, and water took their revenge on the region.
It really feels like a climate change horror story set in the Pokemon universe.
Why on earth would they design this?
We can only speculate based on the files. But remember the soft reboot we talked about at the very beginning of the show? The data wall.
Right, you couldn't trade your old Pokemon forward to then new games.
Maybe the original developer plan was to justify that hardware disconnect narratively. Why can't you trade your old Pokemon from Red and Blue to Ruby and Sapphire? Well, because Kanto is gone.
Oh wow. I'm sorry, Ash. You can't call Professor Oak. His lab is completely underwater.
It's a really grim thought. You have to start over in Hoenn because the old world has literally been destroyed by natural disasters.
That would have traumatized an entire generation of children.
It definitely would have. And clearly they walked it back. They ultimately went with the very faithful, nostalgic remakes in Fire Red and Leaf Green, which was obviously the safer commercial choice. But Pokopia remains in the leaked files as this ghost of a much darker timeline.
It really connects back to the theme of this entire deep dive, doesn't it? Hoenn is a beautiful region, but it is built on broken code and heavily abandoned ideas.
There's even more in the leaks. There's an unused sprite of Professor Oak in the files that looks really rough, very unrefined and sketchy. And there are leftover maps from a Pokemon Festa 2002 tech demo just hidden completely inside Emerald's code. There was even a design document called Project Seed that suggested a massive, sprawling game combining Kanto, Johto, Hoenn, and Sinnoh all into one cartridge.
The absolute dream MMO game everyone always asks for.
But the technical limitations, the exact same limitations that caused the roaming fourth glitch and the clock failures, likely killed it in the cradle. They barely got Hoenn running without the internal clock completely breaking. Imagine trying to fit 4 entire regions on a single 32-megabyte GBA cartridge.
It really changes the legacy of these games for me. We look back at them with so much nostalgia, but from an engineering standpoint, they were barely holding it together with duct tape.
And yet that messy, fragile architecture is exactly why we are still talking about them today.
How so?
Think about it. If the code was perfect, if there were no mask errors or underflows, we would have played the game, beaten the Elite Four, maybe caught a Rayquaza, and put the cartridge on a shelf forever. But because of the Pomeg glitch, because of the arbitrary code execution, Emerald still has a massively thriving technical community 20 years later.
The broken parts let us actually see how the machine works on the inside.
Exactly. When you perform arbitrary code execution, you aren't just a player anymore. You are effectively a developer. You are actively rewriting the reality of the game world. You are taking ownership of that cartridge in a way Game Freak never intended, but that is inherently fascinating.
It transforms the game from a static product into a dynamic tool.
A tool, a puzzle, and a blank canvas all in one.
I want to leave everyone listening with a final thought about that Pokopia leak. If you really think about it, if the original plan really was a destroyed Kanto, do you think the Dexit of Gen 3, the total inability to transfer your old beloved Pokemon, was originally meant to be a story beat? Was that data wall always meant to be a narrative quarantine line?
It's a haunting possibility. Maybe the technical limitation of the hardware came first, and they desperately tried to write a dark story to explain it away. Or maybe the story idea came first, and they just realized it was way too dark for their audience. But either way, it definitely makes you look at that press start screen a little differently.
Absolutely it does. Next time you boot up a copy of Emerald, just remember what's actually in your hands. You are holding a ticking clock, a mathematically broken calculator, and a completely open-ended coding tool, all wrapped up in translucent green plastic.
And seriously, watch out for that Pomeg berry. Keep it away from your low HP team members.
Thanks for diving deep with us into the broken architecture of Hoenn.
Keep exploring the glitches, everyone. There's always more to find.
We'll see you next time.